All right, here we go. Unit 6, radicals and exponents. So today we're going to look at simplifying radicals. Simplifying radicals. Now, you've already done square roots, right? That's what was in your review assignment because square roots is what you use in geometry, the Pythagorean theorem, and the triangles, okay? So that's what your review assignment was with. We are going to up the root, cubes, fourth roots, fifth roots, and things like that. So the first thing we're going to do is I will do a few review problems, but I'm going to add some variables to it. Yes. Okay, so our review. So we're going to put our radicand. This is just a little vocab. The R is the root, right? When you don't have a square root, you have to identify the root, and you do that by putting the number right there. So R is the root. Sometimes we call that the index. That is the decider of what kind of numbers you're looking for. Okay? When it's a square root, you're looking for perfect squares. When it's a 3, you're looking for perfect cubes. All right, so our first example is going to be cube root 54 x cubed y to the 7 and z to the 5th. All right, it's a cube root. That means that I'm looking for perfect cubes. Not perfect squares, perfect cubes. So here's my arithmetic. I don't know my perfect cubes. Maybe you do, maybe you don't. So I'm going to start by writing 54 over here. And I'm just going to start dividing. Okay? As you do more of these problems, you will recognize your perfect cubes, maybe your perfect fourths kind of quickly, but until then, I'm just going to divide by 2 because 54 is even. And then I get to 27. Okay, that's 3 times 9. And 9 is 3 times 3. You have to divide until you either find a perfect cube or you've decided there are none. All right, now I'm going to highlight the bottom of my factor tree because I don't want to lose any of my numbers. So notice that I've got a 2, a 3, a 3, a 3. That's the perfect cube. 3 of a kind. And so when I come over here, I'm going to write 2 times 27 because 3 times 3 times 3 is 27. That's the perfect cube. Now when I'm looking at my x's, that's x times x times x. That is 3 of a kind. So I'm going to write it as x cubed. I don't really want to write out x, 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 x. Okay, I'm only going to do it once just to show you what I'm thinking. Y, 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 y. That's 2 groups of 3, right? 3 of a kind. Well, this is y to the 6th. Why might I choose y to the 6th? Because it divides by 3, right? You're trying to find groups of 3. So if you have 7 y's, how many groups of 3 do you get? 2 groups of 3 with 1 left over. Okay, and z to the 5th. Z, 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 z. Okay, so that's z cubed, z squared. I was trying to break up my exponent into groups of 3 because it's a cube root. Now here comes the extra color. I'm going to circle all the perfect cubes because those are the things that are going to come out of the radical. All 4 of those things are perfect cubes. Right? There's the factor tree to prove it to me. So the 27 Okay, I'm just going to make a little cube root here, and I'm going to decide where everything goes. The 27 comes out as a 3. The 2 stays. X cubed, that's 3 over 3, that's one group. So X comes out, no X's inside. Y to the 6th. Okay, well, 6 over 3 is 2. So Y squared comes out, right? 2 groups of 3. 6 over 3 tells you how many groups. And Y stays in. Z comes out. Z squared stays in. That's the result. Okay, so what are we focusing on that's different from the review? Okay, making sure we identify what kind of root it is, knowing how to split up my variables, and practicing the factor tree to find the numbers that are correct. Okay, so we're going to do a 4th root. 243 x to the 5th, y to the 8th, and z cubed. All right. You do the scratch work that you need to. 243. It's not even. So I'm just going to take my 243 and I'm going to try dividing by 3. I don't know if it divides, but I'm going to try it. Yes?
Isn't there like a thing that you can use where you add up all the numbers and a number and split it by 3? It works.
I have heard of that.
Yeah, I think
So like if you add 2 plus 4 plus 3 and get 9, like oh that is 8.
So if the sum of the numbers divides, it divides by 3. Does that work for like 4s and 5s?
only for 3.
Only for 3s. Okay, so at least you could check 2s and 3s. 5s are easy because it's a 5 or a 0, right? 7s, you might just have to try some of them. But yeah, that's a good one. All right, so we get 8. Oh, that's not bad. So 81. Oh, 81, I know. I know 81. So over here, I'm just going to do a little work. So I see 3 and 81. I know that 81 is 9 and 9. Well, if you can find 2 perfect squares, you found a perfect 4. There it is. So here's the bottom of my factor tree. 5 3s. But I only want 4 of them grouped up because it's only a 4th root. So when I write this over here, I'm going to write 3 and 81 because 81 is the perfect root. That's the one I'm looking for. I'm not going to write 3 to the 5th. Just separate it into the groupings that you need. Okay, x to the 4 and x1, y to the 8, and z cubed. I'm not going to draw out my letters every time. I can do multiples of 4 in my head.
Why is y to the 8 the 1
Okay, so does 8 divide by 4? Yes. So I'm not going to split that up. Right?
Do like 8 to the 4th and then 8 to the x, y to the 4th and y to the 7th.
So the reason I do x to the 4th and x to the 1st is because 4 plus 1 is 5. So now that I've split this up, I'm going to circle everything that's a perfect 4th root. If it's not circled, it stays. Because we're only going to pull out the things that are actually the perfect 4th roots. Okay, so over here I can see that the 4th root of 81 is 3 because I've got the factor tree to show me the 4 of a kind. All right, so I'm just going to write the 4th root and take the 3 out, and the 3 stays. Okay.
I thought the 81 was
No, 81 is the root, right? So what is the fourth root of 81? 3. Okay? So I'm only circling the group, and I'm taking out one of them. All right, so x comes out, x stays. Y squared comes out, z cubed stays. I guess I could put a multiplier, there's a big space there. Okay, it is going to take a little scratch work, especially for the numbers. All right, so we'll do a cube root. Okay, so negative 250, x 14, y squared, and z 19. This one, I want you to try without me. Okay? Just see what you come up with.
That is, you mean -5, right? For that thing.
Yes. There you go, -5. Okay. Do you need one more before I move on?
Yes.
Yep, all right. Fair enough, fair enough. Okay. Four. All right, we'll do a cube root again. Negative 216, x to the 17, y cubed, z 20. Okay. You got it. Okay, so my 216, I'm just going to start dividing by 2 as many times as I can. Oh, and I hit 27. I'm like, oh, I know 27. That's 333. Okay, so I've got the bottom of my factor tree. Okay, so there's the bottom of my factor tree. Because I divided by 2 as many times as possible first, it's kind of in order. So right here, I'm going to write this as -1 times 8 times 27. Because those are my groups of 3. Because 8 is 2, 2, 2. And 27 is 3, 3, 3 from my factor tree. So I know those are perfect cubes. So then I look at 17 over 3, and that's 5, with 2 left over. All right, so this is x to the 15, and then x2.
Does it have to like multiply together or no?
Because they add, yeah.
What if you didn't do the 2? Like, what if you just like wrote it
If you
down?
just know it, that's totally fine.
But then, what would you put instead? Like, if you multiply them all together?
You would just skip straight to the answer.
And it, wait, what is 8 times 25?
Hold on. 8 times 27?
Yeah.
216.
Oh, so could you just write 216?
Yeah. If you know that's a perfect cube, which is 6 times 6 times 6.
I did not know that, but.
Me neither. Until I got there. I was like, oh yeah. Okay, so 20 divided by 3 is 6 with a remainder of 2. All right, so how are you going to write your answer? All right, so we have cube root. Okay, somebody tell me the number, just the number that goes on the outside of the radical. Sure.
6.
6.
-6.
-6, fantastic. So right here, the -1, the 2, and the 3. Only one per group comes out. Awesome. Okay, for the x's, somebody else tell me what comes out, what stays in. Yes, Claire. x5, how did you get the 5? Okay. And then what stays in? X2. All right, for the Y's.
Y comes out and nothing stays in.
All right, Y comes out because look at that, guys. One group of Y's. Okay, Sasha?
And then the Z I brought up Z to the 6 and then left in Z to the 7.
Z to the 6 comes out and Z squared comes in. Yes, okay, so this is Z18 and Z squared. So you're asking the remainder thing. This was me trying to figure out the groups for the X's and the Z's. I was just doing a little division to figure out how many groups I had. Good? Yeah? Okay. Nice work. I am, but I have enough room here.
How many more missed you?
It'll probably take me this much space, and then it'll probably take me one more page. But that's just because I write really big. We have this left, okay, which is not a lot of writing, right? And we have that. That's what we have left.
Say a part of the day.
I can't do it.
Yeah. Yeah.
Absolute value rule. Question? Over here? Okay, so because it's a cube root, I was dividing to see how many groups I had. So for the x's, 17 divided by 3 is 5 with 2 left over. 5 with 2 left over. All right, absolute value rule. Here we go. Do you recall?
Yes.
Love your confidence.
No. Maybe.
Maybe.
It's a long day.
For real. Okay. X squared equals 9, guys. How do you solve that? Fantastic. Okay, what's the square root of 9? 3.
Or negative 3.
Wait, almost. This is what we're getting to. Okay, absolute value. That's why we get plus or minus. Now, I didn't tell you it was called the absolute value rule. I just taught you that's how it simplifies because that's how it simplifies. All right? Now, we know that this turns into the negative and the positive, which means a lot of times from here, we just go straight to, okay, I'm tired of writing it. I'm just going to call it plus or minus 3. But this is the absolute value rule. The square root of x squared is absolute value x. Now that we've expanded into higher powers and roots, we have to be more specific about our rule. It's not just square roots. It could be different roots as well. And so that's what we're going to look at. If R and P are even, and I'm going to show you what R and P are, okay? And, okay, O is odd. Then, all right, so if we have an even root and an even power, if the root is even and the power is even, okay, even. If those two numbers are even, 2, 4, 6, 8, 10, an even number, and the result, okay, whatever power you get on the answer is odd, okay? If O is odd, you have to use absolute value. That's actually the rule, okay? You have to use absolute value. Just like we sort of started doing earlier in the year, now we just have to do it again because we're simplifying radicals. All right? You might ask, why? You might not, but you might. Okay? So, if x to the p, okay, is positive, because anything to an even power is positive. An even power definitely has a positive result. -4 squared is 16. So if you square any number, it's going to be positive. If you square root a positive number, the answer is positive. That's why you put absolute value around it. The answer is positive. The result is positive. Okay, how do we make that happen? An even power is positive. A square root of a positive number is positive. The result is positive. But notice how this exponent was odd. Odd exponents could go either way on the sign. -2 squared is +4. -2 cubed is -8. -2 to the 4th, +16. -2 to the 5th. Okay, so negative times negative, positive. Negative times negative is positive. -32. That doesn't work. It's the odd exponents that give you a problem with the sign. So if you have an even power and an even root, and the result has to be positive, that's why you get absolute value. Okay? So we use absolute value to make sure result is positive. That's why we use it. Okay.
Why does it matter if it's not positive?
If it's they're even, because an even power is already going to be positive.
Like, no, but why do you use it? Like, why does it matter if it's negative? Like, why do we need to use it after negative?
Okay, good question. Let me do
I don't know if my question makes sense.
an example and see if that helps with some real numbers so we can think of some other numbers. Okay, here we go. So I've got the rule. I'll put a little box around it. This is the rule, even, even, odd. Okay, this is an explanation on why we have the rule. Let's use it. Now there's going to be no equals. This is just a radical that we're simplifying. Okay, write the answer. This is an after the fact rule. Just write the answer. X. Cool. Now we look at the rule. Okay, it's even, even, odd. So the root is 2. The root is 2. The power is 2. Both of these numbers are even. And the result is 1. The resulting power is 1. Obviously, I didn't write a 1 because you don't write 1 powers. But the result is odd. All right, that means absolute value. That's what it means.
Is the invisible thing outside
Yeah, no, the invisible is a square root, it's a 2. The invisible is a 2. Yes.
Wait, the question, is it odd or even, or is the result positive?
Odd.
So, if it's odd, it's absolute value. Then what's the thing say?
Okay, so this is why we need it. Okay? How do you ensure that the answer is going to be positive? You use absolute value, right? How do you make an answer positive? You put absolute value around it. Okay? If you start with a positive number under the radical and you root a positive number, the answer better be positive. Okay? That's why we use absolute value, is to ensure the answer will be positive. Yes. Yes. 1 is an odd number. Okay, so let's do another one with some different numbers so we get a chance to see it. So if I do the square root of x to the 6th,
What are our answers?
the answer here is square root, sorry, absolute value of x. Okay, so the answer is x cubed. All right, let's try the rule. The root is 2. The power is 6. The odd resulting power is 3. Even, even, odd. This is the only pattern of even and odd that results in absolute value for the answer. That's it. Even, even, odd. No other combination will work.
So when we basically just get an odd.
No. Even, odd. You have all 3 of those things have to be met.
And so if we just get that, all we have to do is put.
Yes, put an absolute value around it. That's it. Okay. Ready to put it together?
Wait, so if the root is even and the power is even, then the answer must be odd.
Then the answer exponent is odd.
Then it must be absolute value.
Yes.
Okay.
Okay, so let's put some other variables in there so you have a chance to see that. So we'll do a 4th root this time of 81, x to the 8th, y to the 12th, and z to the 5th. All right. Just simplify the radical, guys. Just write the answer, then we'll go back and do the absolute value. Okay, so I know that 9 and 9, 3, 3. Oh, these are all nice groups. Okay, so I'm simplifying. I've got my, so the 3 comes out, x squared comes out, y cubed comes out, z to the 1st comes out, and the 4th root of just z. Okay, so there's my radical, right? There's my simplified statement. Now I have to check the rule. Now, numbers not included. This rule is for variables. So I'm going to check the x. All right, look at only x. So we have 4, right, I forgot, even, 4, 8, 2. 4, 8, 2. No, We are looking for even, even, odd. That is the pattern.
Why are we using 8 instead of like 4?
Say it again.
Why are we using the x to the 8 instead of 1 or 4?
We're going to do each variable separately. Okay? Because the rule, each variable was simplified separately because they're not together. And so when I look for the rule, I'm going to check each letter. So y is even root, even power, odd result. Yes, that pattern matches. Absolute value. Okay. Z, even root, odd power. I'm not even going to move past that because it doesn't matter. It doesn't match the pattern. So the answer is no, no absolute value.
So did you just happen to give us questions previously that didn't have the pattern?
We did a lot of cube roots at the beginning, so it didn't even apply. That's why. Yeah. Question, Rayan?
When you have a number for even and odd?
These numbers? Okay, good question. Here's the root, right? Which goes root, power, result. It's always even root, power, and then whatever that answer is. Okay, guys. Try this one. That's a square root. And we'll do this one, which is the square root also. It is. There you go. Okay. Anyone want to try? Just give me the answer to 4, and then I'll ask about absolute value.
I think it would be 3x y to the second, and then z to the 6th.
Okay. Yes, z to the 6th. Recheck your x and y exponents.
Y to the 3rd. No. Y to the 3rd.
Yes. Okay. What's the x exponent?
X squared.
Yes. Okay. What is left inside the radical? Y. Okay. Somebody different. Where does the absolute value go? Sure.
Wait, sorry, absolute value?
Yep. Where does the absolute value go in this question? Okay. Yeah.
I got, nowhere.
Hold on. Apparently I wrote the question incorrectly, so I agree, nowhere.
Oh, yeah.
It's possible, guys, nowhere.
Why is nowhere the answer?
Because even, odd. All right, so let's check. X's. 2, 4, 2. That's even. So not on the X's. Y's. Even, odd. I'm not even going to go past that because it doesn't fit the pattern. Z's. Even. Nowhere.
So the pattern always needs to be even and odd.
Correct. That is the only pattern. Any other pattern does not apply.
Did we write that somewhere? Like, is that in our notes?
Sort of. Maybe not as explicitly as that. Okay, number 5. Sure.
I got 4x cubed y to the 3rd.
Yeah, okay. Yes, Sasha?
X cubed and Y cubed.
Yes, it goes around, both of them. Okay, so let's check our pattern. So for the x's, it's an even, odd. Yes, right? Even root, even power, odd result. Y's. Even, odd. Yes. Okay, so check. I'll put the little note here. Check. Even, odd pattern only. It's a good note.
So if it is that, then it gets the absolute value.
That's the only pattern that gets the absolute value. All right, so we're going to do the last section here. C, where we are going to multiply and divide. So the one thing we're going to say, there's a little catch when we do our multiplication and division, okay? Just like with the absolute value rule, there's one case that we need to be careful with. There's one case here, okay? So if r, the root, is even, okay, in order to multiply them, we need to make sure that both the a and the b are positive, okay? And that would be the numbers under the radical, all right? So if we have an even root, then in order to do this multiplication and division, we need to make sure that a and b are positive. Okay, so here are the two ways that we can put radicals together. So let's do the multiplication example. So let's say we have, okay, see, even root a, the radicand is positive, times root b, okay? Now, if it's odd, it doesn't matter. So this means, okay, I like to put the arrow in both directions, that you can put the radical, right? You can put both a and b under the same radical, which means you can multiply them. All right, so now let's do the divide example. If, whoop, okay, a over r root b. Okay, so both directions, because you can either put the radicals together or split them apart. So same root, a divide b. Okay, so this is our rule. Okay, so we're going to use this to help us simplify radicals when we multiply or divide. All right, so let's do a multiplication example. 2 cube root 63 x squared y to the 6th times negative 3 cube root negative 21 x to the 70 y to the 13. All right, here we go. So the first thing I do is I have two separate radicals. And so I would like to put them together so that I can combine and simplify. So we're going to go into 1 cube root, okay? Notice that these two pieces are outside the radical. So those two get multiplied together into a negative 6. Okay, the 63 and the 21, okay, so 63 times 21, right, so I need to multiply those. All right, that's kind of long, so I'm going to hold off on that. X squared and x to the 70, so that's x to the 72 for adding. And this is y6 and y13. So that's y19, because 6 plus 13 is 19. All right, so now let's do some multiplication over here. Okay, so I get 1323. Now, I know that I have to eventually do my factor tree here. And so I'm just going to start doing my factor tree right here underneath of it. And I'm trying to break this apart. Well, I know it's not even, so it doesn't divide by 2. I could try dividing by 3, but if I want to do this really quickly, I need to find something that divides it. Now, I actually just did multiplication. So what 2 numbers could you pick to start your factor tree? Let's say I use 21 and 63. I did, however, just multiply them. So I know that 21 and 63 are 2 factors here. And then I'm just going to work my factor tree from here. So 3 and 7, 9 and 7, 3 and 3. All right, so just check the bottom of your factor tree. Okay, because I don't want to miss anything. Now, instead of writing 1323, what if I just did that? What if I just write, okay, so it's negative, so negative, times 21 times 63. I don't need to actually find out what this number is. I can just start the factor tree. Okay, so I'm going to go from here and I'm going to split this up. So I notice here I've got 3, 3, 3, and 7, 7. So I've got a group of 3s. So this is going to be negative 1 times 27 times 49. Right, because we've got 3, 3, 3, and 7, 7. Okay, so I've got my number taken care of. I've got my perfect cubes. All right, x to the 72. 72. So let's check. Does 72 divide by 3? 24. Yes, it does. Okay. 19, so that's going to be 18 and 1. All right, let's take this out. Okay, so we get negative 6 times negative 1 times 3. X to another 24 and y to the 6th. Okay, and we're left with what's not circled? 49y. All right, so I'm going to simplify a little bit out here. So we get 18 x 24 y 6 cube root 49y. Okay, so what was the trick here? Make sure that you can do this multiplication without a calculator. Notice that you didn't need to know the number. You just needed to know what the factors were. Okay, so now I'm going to do a division example. Okay, so we've got square root of 32 x y 7, and I've got divided by square root 2 x 5 y 2. All right. Notice that we have both positive numbers. That means that I can put these together. So I'm going to start by putting them under one radical, just like I did with the multiplication. And then I'm going to try to reduce. Okay, so I got 32 over 2 is 16. X over x to the 5th is, okay, x to the negative 4, which is actually x to the 4th in the bottom. Okay, then I've got y7 over y2, which if I subtract is y to the 5th. So be careful on where these things are located. All right, so the 16 is in the top. The x to the 4th is in the bottom. And the y to the 5th is in the numerator. Okay, now answer. Notice I set up my fraction bar because I got to figure out where this is going to go. So I have fraction outside the radical, fraction inside the radical. All right, those two things are perfect squares. So the 4 comes out, and, okay, look at this, x to the 4th in the denominator, x squared in the denominator. All right, now y is a little bit tricky because it's y to the 4th and y to the 1st. So that's the perfect square. So y squared comes out, and y to the 1st is left. Notice that everything came out of the bottom radical, so it's actually a 1 that's left. Now the square root of 1 is 1. So our final answer, right, so there's my numerator, there's my denominator, and this is how I'll write the final result.